Module 6. Script-based ZTP. Module Objectives. In this module, we will understand an overview of the script-based ZTP process. It is also called as CLI-based ZTP. What are the prerequisites that have to be in place? Scenarios where we can use the script-based ZTP method to onboard Versa SD-WAN branches. We will then understand how to create a template for a device to be onboarded using script-based ZTP. Activating a device using this method. And, finally, we will understand how to verify if a device has been successfully onboarded. And we will also look at a few common issues that you might encounter while onboarding, and how to troubleshoot them. Overview. Script-based ZTP is one of the commonly used methods to onboard the appliance. The appliance has to be activated manually at the branch site. User has to execute a Python-based command line script to onboard the appliance. This requires some level of network and system-level knowledge of the user to the extent of connecting to the appliance and giving the correct arguments in the CLI script. Prerequisites. In order to do a script-based ZTP, we need access to the shell of the appliance, through management interface, or through the console port. Details of the SD-WAN network like local and remote authentication keys for setting up the IKE session. Controller IP address, reachable from the WAN network IP. WAN network link details, like IP address, gateway etc. of the service provider. The WAN link can also be configured to use a DHCP IP, but this information has to be known in advance, so that appropriate arguments can be added in the script. Script-based ZTP can be used in all types of provisioning, and there is no specific use case. However, there are a few cases where this method can be used. If the install base is small, customer does not have the infra for gZTP, or URL-based ZTP. If customer has skilled site administrators, with the know-how of the network, and ability to use the Linux-based CLI to provision a branch. This is the method we can use in case the provider does not support DHCP on the network. In the next section, we will understand how the script-based ZTP works. In this section, we will understand the call flow in script-based ZTP process. Script-based ZTP is a provisioning method, where the site administrator should configure a few parameters in order to onboard the appliance. The parameters include the WAN IP address of the link, the gateway, local and remote authentication keys, and the controller IP address. As a prerequisite, before we do execute the script-based ZTP, the device workflow template, device group, and the device with bind data information has to be configured in the Versa director. On site, first, we need to power on the appliance and connect the WAN transport link to the appropriate WAN interface. It can be any of the ports, depending on the template design. Care needs to be taken to connect the correct transport link on the correct WAN interface, else the appliance will not be able to reach the controller. Then connect to the appliance via the management or console port and execute the script. Once the script is executed, the appliance gets the WAN IP address on the appropriate interface, and via this, it reaches the staging controller, and sets up the IKE session. Once the IKE session is established, the controller informs the Versa director of the new appliance. Then, the Versa director pushes the post-staging configuration to the appliance. Once the appliance gets the post-staging configuration, it goes for a reboot. After it comes in, it establishes IPsec session with the controller, and the SLAs are established, and the MPBGP session is established. In the next section, we will understand how to create a device template, and onboard an appliance using script-based ZTP. We will now understand how to create a device template and a device group to provision a device using the script-based ZTP process. We will also look at updating the bind data information, or the device configuration for the device to be onboarded. To create a template, click on Workflow, Templates, and click on Add Template to create a new template. For this discussion, we will create a simple device template, with 2 WAN transports, and 1 LAN interface and a full mesh topology. Since we have already looked at, in detail, on how to create the different templates in the Versa director, we will just have an overview of the same in this section, covering the aspects that are relevant to script-based ZTP process. Create a SD-WAN post-staging template. Give a template name. The template type will be a post-staging template. Select the organization. Type of SD-WAN topology. Associate the controllers. Choose the analytics cluster. And choose the appropriate service tier. In the Interfaces tab, define the device port configuration. In our case, we have 2 WAN links, and 1 LAN link. We will define VNI0/0 and VNI0/1 as the 2 WAN transports, 1 each for Internet and MPLS respectively. We will define VNI0/2 as LAN interface. For both the WAN links, we are going with static IP, which means they have to be defined at the time of configuring the bind data. Next, give the LAN interface a network name, and choose the IP address as static in this case. Other tabs can be used to configure things like DIA, inbound NAT, and any other services if defined in the design. In our case, we do not have them, and we will now deploy the template. Next, we have to create a device group. Creating a device group. To create a device group, go to Configuration, Devices, and then Device Group. Give the device group name, organization name, and then associate the post-staging template to the device group. Click on OK to create the device group. Next, we have to create the device, that is configure the bind data. We will now create the device, using the device workflow. Click on Workflow, Devices and add device to create a new device. Give the device name, the serial number, and choose the correct device group. And in the Location tab, give the location information. Next, we need to update the bind data information. Click on the serial number to get the bind data window. In this case, we have to give the WAN IP information, the interface IP, and the next hop for both the WAN links. And LAN information that has to be updated with the interface IP. All parametrized values given at the time of creating the template will have to be updated here. Click on Deploy to deploy this device. Next, we will understand how to activate the appliance using script-based ZTP. The user has to connect the laptop to the management or console port of the appliance to execute the script. We will use the staging.py Python script to onboard the device. The syntax is given here for reference. -L for local identifier for IC. -R for remote identifier. -C for specifying the controller IP. -V for specifying the VLAN of WAN link in case of a sub-interface. -S for static IP of the WAN interface to be used for staging. -G to specify the gateway of the WAN link. -W to specify the WAN port. A 0 here corresponds to VNI 0 bar 0, and a 1 corresponds to VNI 0 bar 1. We can also use the -help after the staging.py command line to view the other options. Once the script is executed, and all the parameters are correct, the appliance goes through the ZTP process we had discussed earlier, and finally reboots with the new post-staging configuration. Use the show interfaces brief CLI command to view the post-staging configuration. Verify if the PTVI interface is up, and the correct WAN and LAN IP addresses have been assigned to the respective interfaces, and their VR. After activation, we will understand how to verify if the device has been successfully onboarded, and the service status. Once the device get booted up with the new config, use the show interfaces brief CLI command to view the status of LAN and WAN. The PTVI tunnels towards the controller should be up. If PTVI is down, there could be an issue with the IPv4 reachability between the appliance and the controller. This command also shows the virtual routers to which the interfaces are mapped. Next, we have to verify the branch-to-branch and the branch-to-controller data path. Use the show interfaces dynamic tunnels CLI command to verify if the DTVI interfaces are up. To verify if the SLA is up between the branch and the controller, and between the branch and other branches, use the SLA monitor status commands. If SLA is down between any of the branches, then it indicates an underlying transport issue. In this case, we see that this branch has SLAs up on 2 transports, MPLS, and Internet, towards the controller. But with the other branch, named Global ZTP, it has SLA only on the Internet transport, because the other branch, that is, Global ZTP has only one transport link, and that is Internet. These are some of the basic tests we can do to verify the service status of a VOS appliance after onboarding. More detailed verification steps are covered in the Service Activation Checks module. Now we will look at possible issues which could cause a script-based ZTP process to fail. An underlay transport issue which is causing the branch not being able to contact the controller and initiate the IC session. Check controller reachability from the WAN IP of the interface. If required, do a trace to identify if the packet is getting dropped. Branch serial number not configured, or misconfigured. This happens when attempt is made to push the post-staging configuration, and the director is unable to find a matching serial number. This error can be seen on the tasks window of the director GoA. IPsec SA flapped, and the controller assigns 2 IP addresses. Incorrect parameters given in the script, like local and remote identifiers, WAN IP, gateway etc. This will lead to IC session not getting established. And a possible firewall in the customer environment which is blocking the ports required for Versa SD-WAN. This can be identified by running TCP dump on the WAN interface. Summary. In this module, we discussed an overview of the script-based ZTP process, and how the call flow works. The prerequisites for script-based ZTP. Scenarios where we can use the script-based ZTP method to onboard Versa SD-WAN branches. We also discussed how to create a device template, device group, and a device, and activate the device using script-based ZTP. We discussed basic service activation checks to verify if the device has been successfully onboarded. And finally discussed a few common issues that you might encounter while onboarding, and how to troubleshoot them.